Where in the kitchen, probably within 20 feet of where you are sitting right now, there is a roll of foil, maybe a can, maybe a pot with a scorched bottom nobody wants to admit is still in rotation. That metal is so ordinary, it barely registers as a material at all. It is what things get wrapped in, and what gets crushed and tossed in a bin without a second thought. Now picture a state dinner in Paris in the 1850s. Gold and mirrors and candlelight. The Emperor of France at the head of an enormous table, surrounded by ambassadors, generals, princes, the people whose names get carved into things. At each place setting, the servants are laying down cutlery. The ordinary guests get gold. The important guests get the metal that is in your kitchen drawer. That is the story. Not a metaphor, not internet trivia that falls apart when it gets checked. For a stretch of the 19th century, the substance that now lines a takeout container was one of the most valuable materials on the planet. Emperors flaunted it. A young nation crowned its greatest monument with it. Then, inside a single human lifetime, it fell so far and so fast that the whole idea of what makes something precious got knocked off its footing along the way. This is how that happened. Who did it? What it cost? And why the cheapness of the metal in your hand is the strangest thing about it. Aluminum makes up roughly 8% of the Earth's crust. It is the most abundant metal on the planet. There is more of it under your feet than iron, more than copper, vastly more than silver or gold. It has never been rare. It is one of the basic ingredients of dirt. And yet not one human being in history had ever held a piece of it until the 1820s. Not a pharaoh, not a Roman emperor, not a Chinese dynasty with metallurgy centuries ahead of Europe. Everyone who ever lived, up until about 200 years ago, walked around on top of an ocean of this metal and never saw a single flake of it. The reason is chemistry, and the chemistry is brutal. Gold shows up in nature as gold. A person can find a nugget in a stream, and it is already the thing itself. Iron takes a hot fire and some skill, but a Bronze Age smith could work it out. Aluminum never does this. It never appears on its own. It clings to oxygen with a grip that ordinary fire cannot break. Every atom of it on the surface of the earth is already locked inside a compound, buried in clay and rock and ore, chemically married and refusing a divorce. Heat will not separate it. Charcoal will not separate it. Every technique that unlocked every other metal in human history simply does not work. So the most common metal on Earth spent the entire run of human civilization sitting in plain sight, in the ground, in the pottery, in the walls of the houses people built, completely invisible. Touching it required a force no ancient smith had access to. It required electricity. But that comes later. First came the guessing. In the early 1800s, the English chemist Humphrey Davy worked out that alumina, a common earthy substance, had a metal hiding in it. He could not extract it. He named it anyway, which is a very confident thing to do. In 1825, the Danish scientist Hans Christian Ørsted produced something metallic. In 1827, the German chemist Friedrich Wöhler got a grey powder that was genuinely aluminum, in a quantity a person could squint at. Grey powder. That was the state of the art. The most abundant metal on Earth existed, in the hands of the entire human species, in an amount that would fit on a fingernail. The man who dragged aluminum out of the laboratory and into the throne room was a French chemist named Henri Saint-Clair de Ville, and the reason he could do it was that he found a patron with a military obsession. Napoleon III, the nephew of the Napoleon everyone remembers, was Emperor of France, and deeply interested in aroma. There was a metal, apparently, that looked like silver, did not tarnish, and weighed almost nothing. Think about what that meant to a man with an army. Armor a soldier could actually wear all day. Equipment carried further and faster than any rival in Europe. It was not vanity that opened the imperial checkbook. It was the idea of a French infantry, that could outmarch everyone alive. So the emperor funded de Ville, and in 1854, de Ville published a method. He took what Wöhler had done with potassium, swapped in sodium, and instead of grey dust, he got globules of real metal. He described it to his colleagues in terms that read now like a sales pitch and were, at the time, simply accurate. As white and unchanging as silver, light, workable, and drawn from a source that was effectively inexhaustible. Silver from clay. That was the phrase that got around. At the Paris Exposition Universelle in 1855, de Ville put his aluminum on display, not in a science pavilion, not in a hall of industry next to steam engines and looms. The bars were exhibited alongside the French crown jewels. That is the whole story in one image. The metal that gets crumpled into a ball and thrown in the trash after a picnic was, in 1855, presented to the public as a peer of the crown jewels of France. And the emperor used it the way emperors use things. In 1856, he commissioned an aluminum rattle for his newborn son, the Prince Imperial. In 1858, the silversmith Charles Christoffel presented him with a large aluminum centerpiece honoring his patronage. He approved aluminum eagles for French battle standards. And at the imperial table, he had aluminum tableware, brought out only for the guests who mattered most, while everyone else ate off gold. That last detail deserves an honest note. The specific scene, the ranked place settings, the humiliated ambassador scraping at his gold plate, while the duke beside him gets the good stuff, gets repeated everywhere, and careful historians treat it as a story that has grown in the telling. Some sources call it flatly apocryphal. What is documented is the substance of it. The emperor owned aluminum tableware. It was reserved for the most important visitors. The baby got the rattle, and the metal was shown next to the crown jewels of the nation. The anecdote may be polished, the valuation is not. By the 1850s, the price had come down to somewhere around $17 a pound, in dollars from a century and a half ago, and the earliest ingots had gone for many times that. And Napoleon III never got his aluminum army. The metal came out of de Ville's works in kilograms, not tons, and you cannot armor a division with a substance you could carry out in a suitcase. The emperor got a rattle, a centerpiece, some flatware, and a legend. France got a very expensive shine. Now cross the Atlantic, because the next chapter belongs to the United States, and it is the strangest flex in American architectural history. By the autumn of 1884, the Washington Monument was almost finished. Construction had started in 1848, stalled out completely in the 1850s, sat as an embarrassing stump through the Civil War, and resumed under federal funding in the late 1870s. When it was done, it would be the tallest structure built by human beings anywhere on Earth, and a 555-foot marble needle in a city with summer thunderstorms has an obvious problem: lightning. The monument needed a conductor at the very top, wired down through the ironwork inside and into the ground. The engineer in charge, Lieutenant Colonel Thomas Lincoln Casey, needed a metal for the tip that would conduct well and would never tarnish, because a corroded green blob on top of George Washington's memorial was not an option. The government also wanted something worthy. The tip of America's monument was going to be a precious metal. Aluminum satisfied both demands at once, which is the part people usually miss. It was not chosen purely as a flex, and it was not chosen purely as engineering. It did the job. And at about $1.10 an ounce, it was running right alongside the market price of silver. Put a human scale on it. A laborer working on the Washington Monument in 1884 earned roughly $1 a day for a day that ran 10 hours or more. 1 ounce of the metal in your foil drawer cost a working man a full day of his life. The contract went to a Philadelphia metallurgist named William Frischmuth, one of those minor historical figures who is impossible to dislike and was clearly exhausting to work with. He cast the largest single piece of aluminum that had ever existed, a pyramid just under 9 inches tall, 100 ounces, a little over 6 pounds. He had quoted around $100. He built 225, which took a small war of telegrams to sort out. Then, before delivering it, he took it on tour, without permission. Frischmuth put the aluminum pyramid in the window of Tiffany's in New York, where it sat like a jewel. Then he had it placed on the floor of the store, so ordinary New Yorkers could step over the top of it and go home and tell their friends they had stepped clear over the top of the Washington Monument. Thousands did exactly that. He wired Casey's office, bragging about the newspaper coverage. Casey, who was trying to finish a national monument, sent back one of the great exasperated messages in the history of American public works, telling Frischmuth in plain language that he was embarrassing and delaying the work and needed to bring the metal immediately. Frischmuth brought the metal. On December 6, 1884, in gale-force wind and driving rain at the top of a scaffold 500 feet above Washington, they set the aluminum apex in place. The weather was so violent that no photograph could be taken, so the Washington Post ran an artist's sketch on the front page within 16 hours. 6 pounds of aluminum, crowning the tallest thing on earth, presented to the American public as proof that the young republic could put its hands on the rarest metal in the world. And here is the detail that makes this story almost too neat to be real, except that it is real. That same day, December 6, 1884, in Oberlin, Ohio, a young man named Charles Martin Hall turned 21. Hall had sat, a couple of years earlier, in a chemistry lecture at Oberlin College given by a professor named Frank Fanning Jewett. Jewett had studied in Germany, and he had a sample of aluminum that had come to him from Friedrich Wöhler himself, the man who first made the grey powder. He passed it around the room and made one of the most consequential offhand remarks a teacher has ever made. Anyone who invented a way to make aluminum on a commercial scale, Jewett told his students, would be a benefactor to the world and would also lay up a great fortune. Hall heard the whole sentence, both halves. He graduated in 1885 and did not go get a job. He went into the woodshed attached to his family's house on East College Street in Oberlin, Ohio, and built a laboratory in it. He made most of his own apparatus. He was 21 years old, attempting in a shed a problem that had defeated the best-funded chemists in Europe for 60 years. He was not alone in there. His older sister, Julia Brainerd Hall, was an Oberlin graduate herself and worked alongside him. She kept records. She witnessed experiments. By the family's account and the surviving correspondence, she was a genuine participant rather than a spectator. And when the company was founded, her name is among the founders. History remembers his name and mostly forgot hers, which is its own quiet comment on the era. The key was a mineral called cryolite. Alumina, the compound that holds the metal, melts at over 2,000 degrees Celsius, a temperature nobody was going to sustain in a shed in Ohio. But molten cryolite dissolves alumina at around 1,000 degrees, which is reachable. Cryolite is a strange white mineral that, at the time, came from essentially one place on the planet, a mine on the coast of Greenland. Remember that. It matters enormously in about 50 years. On February 23, 1886, Charles Martin Hall passed an electric current through alumina dissolved in molten cryolite and pulled out small silvery globules of pure aluminum. He ran it again the next day so his sister and his father could watch it happen. 60 years of failure ended in a woodshed, 8 months after the inventor got his bachelor's degree. Then history did the thing history does. Hall filed his patent application on July 9, 1886. The patent office wrote back to inform him that it conflicted with one already filed on April 23, 1886, by a French engineer named Paul Héroult. Héroult had found the same process, independently, in the same year. Héroult was born in 1863. Hall was born in 1863. Both men died in 1914. 2 young men on 2 continents, chasing the same locked door, found the same key within weeks of each other. The process still carries both their names. That is not a story about genius. That is a story about timing. The dynamo had made large-scale electricity possible in the 1870s. Once the electricity existed, the door was going to open. It was only ever a question of whose hand was on the knob. In 1888, Hall took his process to Pittsburgh, where a group of 6 industrialists, led by a metallurgist named Alfred E. Hunt, put up $20,000 and founded the Pittsburgh Reduction Company. On Thanksgiving Day, 1888, Hall and his first employee, a young man named Arthur Vining Davis, poured the first commercial aluminum. Now watch the numbers, because this is one of the most violent price collapses in the history of any material. In 1888, the company could make about 50 pounds of aluminum a day, and aluminum sold for $4.86 a pound. By 1893, 78 cents a pound. A few years after that, 25 cents. By 1914, the year Hall died, roughly 18 cents. 20 years after that first Thanksgiving pour, the company was shipping 88,000 pounds a day, 50 pounds to 88,000, and from the price of a luxury to the price of nothing much, inside a single career. The emperor's metal was now a saucepan. The company had a problem that sounds absurd and was very real. They had learned to make an enormous amount of a metal nobody had any use for, because for 80 years it had been a curiosity for jewelers and emperors. So they invented the demand. They pushed cookware, foil, electrical cable, engine parts. The cookware was sold door to door by college students. The most precious metal in the world was being hawked on American porches by undergraduates working a summer job. Think about what a person born in 1850 saw in one lifetime. As a child, this metal sits beside the crown jewels of France. In middle age, it is 6 pounds of national pride on top of the tallest structure on earth. In old age, a kid with a sample case is at the door, trying to sell them a frying pan made of it. Nothing about the metal itself had changed. The earth did not grow more of it. It was always 8% of the crust, always sitting in the clay under the porch. The only thing that changed was that somebody figured out how to get at it. The moment the difficulty broke, something else happened that people at the time did not immediately clock. The Hall-Héroult process does not require rare ore. Bauxite, the ore aluminum comes from, was identified back in 1821 near the village of Les Bosses in France, and there is a great deal of it in the world. The process requires one thing above all: electricity, in staggering, continuous, industrial quantities. Aluminum picked up a nickname in the trade that is worth sitting with: congealed electricity. A bar of aluminum is, in a real sense, a bar of stored power, which means the metal was democratized in price and quietly concentrated in ownership. Nobody needed to control a rare mineral anymore. They needed to control power stations. Smelters got built where the electricity was cheap and massive, next to falls and dams, and the company that got there first got there decisively. The Pittsburgh Reduction Company renamed itself the Aluminum Company of America in 1907, Alcoa. It bought its own bauxite mines, its own refineries, its own smelters, and by the early 20th century, it was, for practical purposes, the only legal supplier of aluminum in the United States, holding at its peak around 2/3 of the world's supply. In April 1937, the Justice Department charged Alcoa with illegal monopolization and asked that it be broken up. The trial ran 4 years and the trial judge threw it out. The government appealed, and in 1945, a panel of the Second Circuit, in an opinion by Judge Learned Hand, found that Alcoa had illegally monopolized the market in virgin aluminum. Notice what the fight was about: not who owned a mine. Who owned the capacity to turn dirt into metal? That is the second layer of the inversion. The first layer was simply that the metal stopped being precious. This one is stranger. In 1855, an emperor showed status by owning the metal. By 1945, nobody showed status by owning the metal, because the metal was worthless. Status had moved upstream to whoever owned the electricity. Now go back to that mineral in Hall's woodshed, cryolite. For decades, essentially all the world's natural cryolite came from one deposit, at a place called Iviktut, now Ivitut, on the southwest coast of Greenland, the only significant commercial source on Earth. A frozen inlet, a pit in the rock, a few hundred people. Greenland belonged to Denmark. On the morning of April 9, 1940, Hitler's army invaded Denmark, and 6 hours later, the country had fallen. And in Washington, somebody looked at a map and understood immediately what had just happened. Aluminum was not cookware anymore. Aluminum was air power. In a heavy bomber, the metal made up about 60% of the engines, about 90% of the wings and fuselage, and all of the propellers. America's entire war plan, for the war it had not entered yet, rested on building tens of thousands of aircraft. Every one of them needed aluminum. The American aluminum industry ran on cryolite, and the cryolite came from a hole in the ground that had just, on paper, become the property of a country under German occupation. What happened next is one of the least famous critical moments of the war. On May 3, 1940, the Danish ambassador to the United States, Henrik de Kaufmann, went around his own occupied government and requested American assistance, an act that could have seen him tried for treason. On May 10th, the Coast Guard cutter, Comanche, sailed from New England for Greenland. 4 more followed, one carrying guns. The United States invoked the Monroe Doctrine, negotiated with the Danes in exile, and took Greenland under its protection. American coastal artillery was in position at Ivitut by September 1940, more than a year before Pearl Harbor. Eventually, more than 500 American soldiers guarded the mine, and the 100 to 200 miners who worked it, with naval and coast guard bases nearby and heavy guns sighted to fire on German submarines. Production peaked in 1942, when 86,000 tons of cryolite shipped to the United States and Canada. Sit with the shape of that. American boys with rifles standing in the Arctic, a year before their country was at war, guarding a pit of white rock. Because without that rock, the bombers do not get built. There is a direct line from a professor's lecture sample in Ohio to a gun emplacement on a Greenland fjord, which is exactly what makes the other half of the aluminum war so uncomfortable. Bombers needed virgin metal, fresh out of the smelter, and that is precisely why a hole in the ground in Greenland was worth 500 American rifles. But at that same moment, on both sides of the Atlantic, governments were going door to door, asking their citizens for the one kind of aluminum a bomber could not use. In July 1940, Lord Beaverbrook, running British aircraft production, made a public appeal for aluminum. He wanted it. He wanted it now. New and old, of every type. His pitch was blunt and brilliant. Give us your pots and pans, and we will turn them into Spitfires and Hurricanes. The response was extraordinary. 1,600 collection centers went up across Britain. Saucepans, kettles, colanders, tea trays, pot lids came off the shelves of houses that had nothing else to give. Around 70,000 tons came in. America ran its own aluminum drive in 1941, and millions of people carried their cookware to central depots. The trouble is what happened to it. The aircraft industry needed virgin metal, the same narrow category the courts would later rule Alcoa had monopolized, and it is widely documented that much of the material collected from kitchens was not suitable for aircraft. The historian James Kimball describes citizens rushing to pile up their pots, while the government dithered over what to do with the heaps, which sat where they had been dumped. Among people who study the home front closely, the 1941 aluminum drive is remembered as the campaign that soured the public on scrap drives. The honest version is not a clean debunking. Some of the collected metal did get used, somewhere, in some form, and later drives for steel and copper and tin genuinely mattered, but the specific promise, your saucepan becomes a Spitfire, was closer to a morale operation than a supply chain, and a lot of families gave up the only aluminum they owned on the strength of it. Which lands on a bleak little irony. 90 years earlier, this metal was so precious that only an emperor's honored guests were allowed to touch it. Now it was so common that a government could ask every household in the country to hand theirs over, receive 70,000 tons in a matter of weeks, and then not be entirely sure what to do with the pile. The story does not end with the metal becoming free. It ends with somebody else paying. Bauxite gets mined, mostly in the tropics, mostly in places that do not consume the aluminum that results. It gets refined by the Bayer process, invented in the late 1880s, right alongside Hall and Héroult, which dissolves the ore in caustic soda to extract alumina. What is left over is called red mud, rust-colored, enormously alkaline, produced in quantities measured in billions of tons across the industry's lifetime. It goes into reservoirs behind embankments, and it stays there. On October 4, 2010, at an alumina plant near Ajka in western Hungary, one of those embankments failed. Roughly 1 million cubic meters of red mud came out at once and went down a creek into the villages of Kolontar and Devekse. It ran 2 meters deep in places. Its pH was around 13, which is to say, it burned people. 10 were killed and hundreds were injured. It poisoned the Markal River and reached the Danube. It was visible from orbit. The reservoir had been flagged as an accident risk years earlier on a watch list. In Jamaica, where bauxite has been mined for generations, a columnist wrote in the aftermath, asking the obvious question about the red ponds sitting on his own island, where the rock underneath is porous limestone. That is the third layer of the inversion, and the one that never makes the trivia lists. The metal became cheap. The cost did not vanish. It moved offshore to people who will never own anything made of it. Here is the last turn, and it goes the other way, which is the only reason this story is not simply a downhill slide. Aluminum is almost uniquely well suited to being used again. The atoms do not degrade. Melting existing aluminum takes roughly 5% of the energy needed to make new aluminum from bauxite, a saving of about 95%, one of the most dramatic efficiency gaps in the entire recycling economy. The industry's own accounting claims that around 75% of all the aluminum ever produced is still in use somewhere today. Treat industry figures with the appropriate squint. But the physics is not in dispute. Congealed electricity can be thawed and refrozen over and over, and almost all of the original power stays in the metal, which means the can in your recycling bin is not garbage. In a strict energy sense, it is the most valuable object in that bin by a wide margin, a small ingot of stored electricity somebody already paid for. Bury it in a landfill, and that electricity goes in the ground with it, and somewhere a smelter burns the power again to replace it, and a bauxite mine takes another bite, and a red pond gets a little deeper. One last thing about the 6-pound pyramid at the top of the Washington Monument. It never came down. It is still there. It turned out to be a mediocre lightning rod. Within a year, a strike cracked the marble underneath it, and engineers had to girdle the pyramid with a copper band and run rods down the corners. Between 1885 and 1934, lightning blunted the tip. About 3/8 of an inch of the most expensive metal in America was vaporized off the top by weather. But the pyramid itself is still sitting up there tonight, 555 feet over Washington, exactly where Frischmuth's crew set it in the rain in December 1884. In 1884, that object was a national statement. 6 pounds of the rarest metal on Earth, worth more per ounce than a laborer earned in a day, shone in the window of Tiffany's, stepped over by thousands of New Yorkers who wanted to say they had walked across the top of the tallest thing humans had ever built. At today's scrap prices, those same 6 pounds are worth a few dollars. Nothing happened to the pyramid. It is the identical object. Same atoms, same shape, same spot in the sky. Everything that made it precious in 1884 lived in the heads of the people looking at it, and specifically, in one fact. Nobody yet knew how to get the metal out of the dirt. A 21-year-old in an Ohio woodshed removed that fact from the world on a February afternoon in 1886, and the value of the thing on top of the National Monument collapsed without anyone laying a finger on it. That is what makes aluminum the most quietly unsettling material in the house. Not that it was once worth more than gold, that it stopped being worth more than gold without changing at all. Every precious thing is precious for a reason, and the reason is almost never the thing itself. It is a difficulty, and difficulties do not last. Somewhere right now there is a locked door that makes something expensive, and somewhere there is a person in the equivalent of a woodshed working on the key. With no idea, they are about to reach into rooms full of powerful people and quietly empty their pockets. The foil is in the drawer. The emperor is dead. The pyramid is still up there, blunted by lightning, over a city that once thought it was the most valuable thing in America. Everything in this video is a personal perspective, pulled together from a lot of different sources. Sometimes, a personal perspective is not as interesting as you were hoping it would be. If that is the case, put your own view down in the comments where I can see it. And yes, I read every single one. So, a question worth answering honestly. If aluminum went from crown jewel to garbage in 70 years while staying the exact same substance, what is sitting in your house right now that is only expensive because nobody has cracked it yet? There are a lot more of these hiding in plain sight. The kitchen is full of them.